Hello and welcome to SW in the nice Black Forest in the wintertime of 2020. My name is Rainer Fries, I'm the General Manager of Sales, and I'm here with
Andreas Hangst is my name. I'm responsible director for technology division here at the SW headquarters in Waldmössingen, and I'm very happy to introduce to you, together with Rainer Fries, now our latest machine, the BA space3.
Andy. When we create a new name, space, and what is the 3 for? Space is a pretty wide open word, but 3, what is the number telling us?
I mean, for space, I guess it's easy visible behind us. It's just big machining area, and the 3 in this case stands for the travel. The maximum travel here in the x-axis means we can load and machine parts up to 3 meter length.
What are the other major dimensions on this machine?
I mean, there are of course more. We have then in height, means in the vertical direction, it's 1.8 meters maximum machine travel, workpiece size, and in the third dimension, in the z-axis, it's 875 millimeters.
So actually that's the biggest machine we made under the SW name, and it's exciting. We have introduced other sizes in the past, but this one is bigger. Explain to our viewers why we made this machine.
I mean, major reason for developing this machine, and especially the size of the machine, was the increasing size of light metal, aluminum, magnesium components, especially in new developed cars. And this, let's say, brought us to the idea to develop this special machine so that we have a very dynamic but also big machine to have the best possible manufacturing solution for our customers.
And you said 2 words, big machines. Big machines are not typically made with linear motor drives, and not so many with torque motor drives in the rotational axis. And when we develop new machines, we look what's necessary on the market. Automotive is our biggest customer base, and the lightweight and e-mobility has driven to be more casted parts than parts which were bended or cast iron. So this machine was again tailored for the more aluminum lightweight parts. Not so much machining, Andy, right?
Yep.
Actually less chips per part, but we have to be fast. So what about the speeds?
Yeah, I mean, that's also probably the fastest machine in the market at the moment in this size. We have a rapid feed rate of up to 120 meters per second, and combined with an acceleration of up to 2G. So this results in a chip-to-chip time of 4 seconds, and combined with the spindle ramp up time of 0.8 seconds, what it is. So we have even, let's say, reduced the so-called non-productive times to a minimum also in this size of machine.
When you say chip to chip, we have quite a travel from the tool magazine to the center of the work zone where it has to be measured, and so it equates to an extremely fast chip to chip time with that size of machine. We're launching it right now, and actually we also got a program for that. In that case, for the program, it's a pretty flat part, so we can use don't need the 800 millimeter Z-axis we actually have. But if you have other parts, we are happy to analyze which is a suitable machine. But coming back to that machine in particular, I think we have only 6 leveling wedges, right?
Yep.
So what about the installation time?
Like the installation, I mean, this machine is can be shipped in one piece, so it's kind of like, call it a hook-on machine. It has only these 6 installation pads, and it's roughly about 1 week needed only for installing it at the customer and making it ready to run.
So it's more or less like any other machining center we make, and the fact that it's wider, yes, I think we have to take off a few things.
Yep.
Like this platform here we see. The platform, I would say, is typically not used in production any longer, because how do we feed the parts into the machine, Andy?
I mean, of course, with the platform, you see there's a manual loading possible, but normally due to the possible size of the parts, it makes sense to do an automated loading, either with a robot having in front of the machine or a gantry loading system. So that's probably the more convenient and in the end for serious production, the more cost-effective way of loading and handling the machine.
And as you can see with the background, the door is wide open, so you could even load from the top or from the front, or a combination with a robot or a gantry. But Andy, what's happening inside? We have a straight fixed spindle and we have the tilting head, two-axis tilting head.
We have two options. Let's say standard is just a 3-axis unit with a straight, with a fixed spindle. And alternatively, we have a swivel head as an option, a so-called AC axis, for being able to produce any compound angle that's needed maybe in the part. So this swivel head is a SW design, so we made it, developed it on our own. It's two direct driven rotary axes with torque motors inside. It's more or less the same type of drive that we use already since many years in also our other machining centers. And we're the opinion that this is now the perfect combination for this machine to give it the needed flexibility, but also to be able it in the needed, let's say, speed and short cycle time.
Yeah. So we can even machine from the side with the swivel head, and I think that makes it very versatile for big parts. And when you will see it moving and running, it's actually also the swiveling action is very fast. I repeat what Andy already said. We have about 20 years experience in making our own torque motors on rotary axes. So Wolfgang Amlede, the head of design, applied that here on the swivel head unit, and also with an SW spindle inside. That package is very versatile, as small as possible and as powerful as the space allows. And so we can machine. Do you expect any, let's say, hiccups in machining the parts?
And what we noticed is, even due to the size of the machine and especially the size of the 3-axis unit where the spindle moves inside the machining area, the machine is still very stable and very, let's say, calm and balanced for milling operations. And I mean, also what we have, let's say, in this small type of spindle, we still have 20,000 RPMs possible, so that's also a very important feature and point when running these light metal applications. So therefore, I think it's really a very well done and developed machine design, and we are happy, of course, then to do now more custom applications with it.
Yeah. One of the features we have now also on the Space as a standard is our new touchscreen, quite wide, quite big. You basically operate it like your smartphone. You can have different screens and modes which you basically customize for yourself, and it's easy and quick. It also has a force feedback, so when you do something with the hand wheel, you will always know where you are. And I think, Andy, when we change tools, how do we get the data into the machine then?
Either it's possible to have it through a network connection, but also if you do it manually, we completely developed a new HMI, like a user interface. It's a workflow-based process, so that it's for the operator very easy and with less risk of mistakes to put in the needed data for the cutting tools and then to start up a new machining process.
So, and you can take this pad, this computer pad with you, then go even to other machines of the same kind, plug it in to be safe and be allowed to operate all safety related functions. But this is coming back to our machine, the space3 here, is one thing which I think we can still claim for us. It's, for that size of machine, the fastest on the market, and who doesn't believe that can challenge us anytime. That's not a problem. And the cycle times we're going to achieve, Andy, that's also your responsibility within your team, cycle time calculation and fixtures. What can you tell us about possible fixtures on that machine?
I mean, here, as said at the beginning, due to the size of the machining area of the table, we are able also to introduce and install fixtures up to 3 meters width and 1.6 meters in height. And then these, like it's a twin table machine, as we call it. So we have 2 work tables, means one fixture, one part is always inside the machining area getting processed, and parallel to this, simultaneously, we can load and unload the other table, means the finished part from the last cycle. So this also helps to reduce the downtime or the stop time of the machine to a minimum. Actually, only the rotation of the swivel carrier is about 4 seconds in time, and that's the only time where the machine is not making chips. So that's also a very nice feature, and also this follows our philosophies from the former machining centers. We also could introduce it here, and we even have the possibility to rotate the swivel carrier between 0 and 16 degrees while still machining inside the machining area, maybe to use then some gravity for load the parts. So this is also, I think, a very nice feature, especially when loading these big parts.
Yeah, that's a cool function. Also cycle 800 will be required when you use a swiveling head, but that's a programming strategy which is very common right now. And but just a reload or downtime of 4 seconds when you change pallets is, again, for that size of machine, I think very, very small. And we still work in the zone inside, and the travel will allow us to machine these big parts. Other than that, Andy said most of it. If you are a user of an SW already, you will have no issue in moving to that machine and use it, because the layout around the machine with hydraulics and pneumatics more or less the same. And so there's very little, let me call it, retraining necessary. The programming will be some challenge if you haven't machined with a 5-axis machine yet. But is there any other?
I mean, as you just said, for the, let's say, if you have the fixed spindle version, it's even the same type of programming, conventional DIN code, CNC programming. And for the swivel head, yes, you need the CAD-CAM system, but besides that, the C1 control panel is the same as also now in our other machining centers. The HMI is the same. Also the integration with our live data services for remote diagnostic, for preventive maintenance and so on is also the same. So let's say from a user point of view, we really try to have almost identical HMI, the interface, to make it as easy as possible for our customers to run and operate the machine.
You mentioned one thing, our remote services, our industrial data service package with an IPC on board of each machine, but also what's new here with the space3 is the IO-Link connection. So from all kinds of sensors we collect the data, whether it's pressure, which is a level of a fluid, or of course of, for example, a scale. We collect more and more data and through the HPC in the machine we're going to transfer data either to our cloud platform, which we started last year, and actually also through an MIS or into an ERP system at the customer's end. That will be more or less pre-selected what you as a customer would need and what we from a machine standpoint would like to have, as well as your maintenance team to see on a portal with some nice covers and layouts to see what is the machine doing, how is it behaving. So in that sense we are also claiming that we are state-of-the-art with that concept of our remote access and the depths of data we can analyze. And we guess that, we also have to do automation in any case with that machine because parts are just too big. Is that right to say?
Yep, I mean, that's true for this size of parts, and also normally the weight, which is less than what is the normal ergonomical allowed, let's say, part size to handle. It makes sense to automate it, to run it, for example, for a robot. We have solutions that we have a gantry robot on the portal to come from top, then we can even leave the loading door closed, we just have an opening on top, or also we can use a floor-mounted robot. It depends on the customer's preferences and which is, let's say, the best suitable solution for the manufacturing system.
You mentioned the clamping, how big a fixture can be. On one of our current programs, I forgot how many of clamps do we actually have on one fixture?
I mean, there we have up to, I think it's 25, 30 clamps around. We even combining pneumatic activated clamping elements with hydraulic, which is normally our standard clamping elements. So we have there also the full flexibility. We have through the rotary joint of the swivel carrier. We have up to 16 tracks for any media either if it's hydraulics, pneumatics, or even electric cable if needed for some applications which might be in the future. So there also we try to keep as much flexibility as possible, really to develop the best, also tailor-made clamping solution for the customer's workpieces and applications.
And what Wolfgang, our head of design, told me that the machine is running very, very smoothly. Have you watched some of the machining it did already?
Yes, it did, and it was very, very exciting, especially the swivel head, which is kind of a new feature for our machining centers. It was very great to see how fast, how flexible, even this travels from one edge of the machining area to the other, which is about 4 meters in distance, and so that's really amazing, and I think we can do a lot of new applications, also new challenges in the end for us, and bring it to a successful end for us and for our customers, so that we have a win-win situation, which is the best for all of us.
Yeah. And with that speed, I think we stay actually in line with the current other products we have with the W06 and W08. So we adopted that. It's a single spindle machine at the moment. Questions might come up, when will SW do a twin of that? We will have to extend the machine a little bit more, have to give it another tool magazine and stuff, but nothing is impossible, and if the demand is high enough and the cost per part calculation would prove that a twin spindle machine makes sense, Wolfgang, our head of design, will also work on that. But let's get started with this here. Any other features from your side, Andy?
You just mentioned the tool magazine. That's also, I think, an important point. Here we also have the same possibility as in also our other machining centers to have a scalable cutting tool magazine. Standardly, the machine has 40 tool pockets, and there's an option of increasing it to 80. So that should be sufficient tool pockets available for doing any complicated part, completely machining in one setup.
And we also have a carryover of a number of features which are important for the process, in particular for the machining process. One is our inductive broken tool detection, which is more or less cycle time independent, right? So we don't lose time.
0.1 or 2 seconds.
0.1 or 2. The second is a so-called plane phase control on the spindle, which we have even, let's say, tuned or improved with the last generation. So tiny chips up to, I think, 0.2 micron will be detected.
Yeah, a little bit more, something like that. Yeah,
okay.
We have them.
And that will take a little bit of time, and I think also very important for the final touch-up of a workpiece is a feature called the run-out control, contricity measurements, and how do you control the run-out when you have a tool clamped. Basically, you need to check at as close as possible to the tool tip.
In the end,
right?
at the cutting edge. I mean, there where you do the chip is more or less produced. That's the most important feature, that you have the accuracy there. And with our system, where we have the sensor is mounted on a small NC axis, so depending on the tool length, we always can measure the concentricity of the tool when it's rotating directly at the cutting edge, and this leads us to an accuracy of up to 5 microns run-out detection, which is much more accurate than as, let's say, with other systems, when you detect it at the end of the tool at the HSK or tool plane phase interface. So I think that's also a very nice feature and very important for process control, and that's in the end been one of the main tasks of this machine, to run 24/7, 365 days a year, to bring the quality, the required day by day and week by week, and I think that's also a good thing that helps the customers to keep that going.
From knowing, working with your application engineers and the guys who program the machine, what was the first feedback about the new one?
They liked it. I mean, one thing is that with the HMI, with the control panel, with the software interface, it was very easy to get it to know, to get introduced to it, to run it, to program. And then also, let's say, especially with the swivel head, they like the new possibilities that they have, the bigger flexibility. And so they were really happy to run it and to do it so. And I think that's the right track and the right product for this.
So thank you, Andy. We talked about a number of features of the machine. So typically the next step is then in your hands My sales guy is going to attack the customer and see what programs are around, and you, your job in that?
And then we will do the tailor-made solution, we do the process design, we do the quotation, and in the end we do whatever it's needed to produce quality parts in the shortest possible cycle time, and then of course to give you the best solution that you can find.
Including automation, so that comes also out of your team. And if you want to know more, please send us an info, an email, whatever, get in contact with us, and I look forward to see you here soon as it is allowed. Too bad we cannot make you come here, but surely next year. Dankeschön.
Yeah, thanks for watching, and looking forward to see you.